in a way to sustain.
In the previous video, we saw that energy is currently described using both wave-like and particle-like characteristics. We also realized that wave and particles may simply be the terms we use to describe the phenomena about atoms, space, and energy that we do not yet fully understand. One experiment forced physicists to rethink the very nature of energy. The photoelectric effect. When light falls on a metal surface, electrons are emitted only if the light's frequency exceeds a specific minimum value called the threshold frequency. Below this frequency, no electrons are emitted, no matter how intense the light is. This single observation shattered classical physics. Classical theory predicted that increasing intensity should allow electrons to gradually absorb energy and escape over time. But that never happened. No amount of intensity could compensate for insufficient frequency. And once the threshold frequency was crossed, electrons were emitted instantly, not gradually, not continuously. Classical energy formulas failed. This left only one logical possibility. Energy was not being delivered smoothly, it was arriving in fixed, indivisible portions, each portion tagged with a specific frequency, not adjustable, not divisible. If the incoming energy portion did not carry the minimum required frequency, the electrons simply ignored it. This discreteness of energy exchange is what we call quantization. Einstein showed that each interaction between light and an electron involves one such energy packet proportional to the frequency. If the packet is too small, the interaction does not occur. If the packet is sufficient, the electron responds instantly, not because of force, but because of the rule imposed by nature. Soon, the same rule appeared everywhere. Atomic spectra, molecular vibrations, nuclear transitions. Quantization was no longer an assumption, it became unavoidable. So what did we miss earlier? Nature does not allow energy to exist as a smooth, continuous flow. It exists as discrete patterns of allowed frequencies. Imagine a vast auditorium with many strong entry doors. No amount of pushing can break them open, but each door recognizes a specific access card. The moment the correct card appears, the door opens instantly, letting the person to unfold the chair called electron inside the auditorium. Intensity here is pushing, frequency here is the access card. So quantization in one line is nature saying energy does not flow freely, it arrives only in allowed steps. In the previous video, wave-particle duality showed us something unsettling, that energy refuses to be just a wave or just a particle. Quantization goes one layer deeper. It tells us that even waves and particles are not continuous. They interact only in specific amounts, never in between. So is quantization the final description of reality? We honestly do not know. It could be a fundamental rule, the smallest language the universe speaks, or a surface pattern of a deeper structure not yet discovered, or evidence that reality itself is discrete at its core, or simply another powerful model waiting to be surpassed. Or perhaps there exist boundary layers that connect wave and particle behavior and force nature to appear discrete. Quantization is not the end of curiosity. It corrected classical physics, it gave birth to quantum mechanics, and it continues to remind us that the universe does not behave the way common sense expects. If wave-particle duality shook our intuition, quantization disciplined it, and whatever theory comes next, it will surprise us even more. Let's keep questioning, let's keep exploring, let's innovate to sustain. Watch our other quantum topics in this playlist. Don't forget your formalities to our channel. Nandri, Vanakkam.